This is chapter 21, more about tests. So to start out here, let's talk a little bit more about p-values. The p-values tell us the probability that something would happen by chance given the null is true. Remember that, given the null is true, this would happen by chance this percentage of the time. That's why when we say when the p is low, reject the ho. Because if we're saying if the null is true, this would happen 1 in 1,000 times, well, I don't think the null is true. If the null is true, this would happen 1 in 1,000,000 times. I don't think the null is true. If the null is true, this would happen 1 in 2 times. Well, that seems possible to me. So we need to remember also that we get to pick what low is by picking alpha. We get to pick our alpha levels. Basically, a small alpha level means that we'd be rejecting with more confidence. But let's talk about some of the mistakes that we can make here. Some of the mistakes we can make are a type 1 or a type 2 error. And what I want you to remember is 1, 2, positive, negative. This means false positive, false negative. It's very important that we get that down. If we have a type 1 error, we have a false positive. This means if you go to the doctor, they are going to have the null hypothesis that you're a healthy human being. They're going to have the alternative that something's wrong with you and you're sick. So if you have a false positive when you go to the doctor, they're going to say you're sick. But remember, it's a false positive. They're going to say you're sick when you're not actually sick. What they've done here is they've rejected the null. So in a false positive, you reject the null. Now when we get to a type 2 error, remember 1, 2, positive, negative. It's a false negative. So when you have a false negative, you are actually going to say that someone is healthy. The doctor says nothing's going on here, there's negative results, nothing going on, your test came back negative. But it's a false negative. The doctor says you're healthy, but you're actually sick. Now let's talk about it in context to maybe testing a mean. If we think that the students have a test score, or we test the null hypothesis that the students' test scores are equal to 80, with the alternative that they're greater than 80, well, in a false positive, type 1 error, we would say, aha, the students' test scores are greater than 80. We would reject the null and show evidence for the alternative. This is a false positive. We have results. But the students' test scores were not actually greater than 80. Now, in a type 2 error, we fail to reject the null, where we say, oh, the test scores, they were equal to 80. That was our null. That's what we began with thinking. But we should have rejected, because this is a false negative. We should have rejected the null. This takes a little bit of time to get down and think through more examples. Right here you see a grid of it. This sometimes helps people understand it a little better, where we say that the truth is that the null is true. And what we did was we rejected it. This is a type 1 error. Remember, false positive. When you reject the null, what we do, you're going to have positive results, but we shouldn't have done that because the null was true. This is a very good thing to get down. Make sure you get this down. It's easy questions on the test, I often think. One last thing we need to understand is that alpha controls the type 1 error. As alpha increases, type 1 error increases. Beta controls the type 2 error. As beta increases, type 2 error increases. We're also going to see this when we get down here to power. Power is described as 1 minus beta. We can't actually find beta. So it's because we don't actually know the truth out there. If you're at the review, you might have saw this a little more in depth, but alpha controls type 1 error, and beta controls type 2 error, and the power of the test is the ability to correctly reject more false nulls. If you're looking for right here it says, the power of a test is the probability that it correctly rejects a false null hypothesis. Right here on the screen is the book definition of power, and here is the formula for power. Let's scroll down a little bit and talk about the 3 things that affect power. Effect size. This is to say that if a student's test score, if we find out that the test score for students is 90 and we're testing against 80, that's a big effect size. If the test score for students is truly 82 and we find 80, the effect size is a lot smaller. So it's much easier to detect a higher effect size where the difference is greater. Alpha level, which is what we affect right here, and the sample size. Good slide to review over that just goes over all the things that impact power. This is the last part right here before class activities. Make sure you get this down. These 3 things impact power. Have them down and know them well. Good luck.